Hey everyone, thanks for joining us for the next session of our Agentic DevOps Live series. My name's Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I would love to turn it over to our presenters for today. Lupita, Rohan, thank you so much for joining.
Thank you so much, Anna, for that lovely introduction. Welcome, everyone, to another Reactor series. Specifically, today is the Agentic DevOps Live. With me is Rohan. I'll let him introduce himself, and then I'll introduce myself and walk you through what to expect.
Hey, everyone. My name is Rohan Parak. I'm Staff Product Manager here at GitHub Advanced Security team.
And I'm Lupita Caraves. I am an ACE, an Application Security Executive. I've been with GitHub for about 3 years, and my focus is technically the security stuff, but now in the new era of AI, they have come to be better together in every way. And so what we're going to be talking about today is how to get secure and stay secure in the world of agentic AI. For those of you joining us for the first time, the Reactor series serves as an opportunity for you all to receive ungated content. So we absolutely really hope everyone registers for all of these events in this series so that you can get up to speed and in the know of what's happening. So let's go ahead and get started. With the first slide, we're going to talk a little bit about application security, right? In terms of what that means. So Rohan is going to be leading the slide deck here for me. But basically, if you've been in this space long enough, which I have for about a decade, you've had experience, different opportunities to use different solutions. But traditionally, it's kind of always been a siloed series of events that occur between security and development. And now we're realizing application security is a team sport. It requires both teams to collaborate in order to succeed. And I know from a GitHub perspective, we have proudly made that experience so much better, that collaboration, because it's embedded into the native experience that they're in and their flow state, just works really well. However, the industry reality is that there's still remediation trends that are remaining stagnant. Applications are being pushed to production with known risks for whatever reason, prioritizing, the experience, the features, the functionality. And so sometimes security still becomes an afterthought. So as quarters and quarters go by, you see those numbers trending upward and to the right. So what I found to be the primary cause of these issues are two things. If we look at in more detail, securing the developer workflow is tough because how do you prioritize or how do you know what to actually fix? Even though code is being developed more faster, why are we not actually fixing these vulnerabilities as they're coming in? I've heard many security professionals say it's the developer's fault, that they just don't care about security, but I've worked with thousands of developers. I was a developer at one point, and that's just not the case. The main issue is that AppSec tools have never been designed to fit the flow of the developer's experience. They fail to understand that applications, are built very quickly, especially now with the era of AI, where Copilot is providing suggestions out of the gate. But that pace just doesn't align with what we're seeing with the security type of attacks that are now being created. So that being said, because traditionally it's been bolted on, not built in, and they've sat outside of the, developer flow state, it's created a lot of friction, and developers really don't have the time or the interest, to remediate. So I wouldn't say it's a thing about motivation, but more so just figuring out how we can make it so that they naturally have security embedded into the process. So it's sort of like a plug and play. right? Because without that, it just becomes super expensive because you don't know if you should be fixing this finding or that finding or how to prioritize what's most important to the business. So I'm a strong believer that if we don't figure out the remediation piece in terms of it being automated, that we're just going to, break this cycle. So how do we dig into those details and how do we define that? So if we look at what we're working with here on this next slide, we have the CISO who wants risk reduction and prevention, and the CTO who wants innovation and productivity. Well, that can be a little bit of a challenge, right? Deciding like what takes priority. But at the end of the day, it's like, despite the trade-offs, we know that there's real issues with AI now being used to create more complex type of attacks. And so it's super important that we are building security into the process by default, right? So as security wants engineers to reduce the risk, development wants to keep moving fast, but how do we kind of like merge those conflicting goals? Well, let's look at AI in general on this next slide. Is it a villain or is it a hero? There's like competing thoughts about this, right? But for the past decade, organizations have been dealing with the security challenge of like discovering more vulnerabilities and fixing more vulnerabilities, but the backlog just like keeps to be the same. And sometimes people don't even know what they don't know because they choose not to know, right? As soon as you know, then you're responsible for going in and remediating or mitigating those findings. And that can be a challenge in terms of timelines, priorities, and what gets pushed to production. So the security debt for most organizations has been compounding. And so here's the good news or the bad news. I say AI is changing everything, right? Is it a villain? Is it a hero? I don't know. I think we're going to dive into like both scenarios and see like what that really means. So on this next slide, let's look at it as if it were the villain. AI has fundamentally changed the equation. As we know, the number of reported AI-enabled cyber attacks has grown by like 47% globally. This surpasses around 28 million AI-driven incidents. These actors are using AI to accelerate and automate attacks that are just becoming way more complex. I think I just saw something online about someone using ChatGPT and Claude to infiltrate Mexico's government, and that's scary, right? So how do we prevent these types of things from happening? It's not just about looking for vulnerabilities. It's actually about fixing them. We here at GitHub say found means fix. That is our philosophy and approach to tackling this problem. I always say when it comes to developing software and applying application security concepts, the cheapest flaw to fix is one that is never written, right? So if you can shift left as close as possible to the moments where developers are writing and coming up and creating that code, by the time it gets to QA or by the time it gets to security checks, it would have already reduced the number of attacks that could potentially have an impact. This is a challenge that every organization has. I worked with small companies, big companies, and they all kind of have a different level of security tolerance, security posture. And so what we're hoping today is to show you like what's going to happen if we don't change our culture. So that being said, when we look at this graph here, if nothing changes, we'll see what is known as a collapse of AppSec. And I'm sure you've seen this in the news about all these cool tools that are popping up with like AI functionality, being able to detect stuff. But I always like to bring it back to like what application security actually is. And from a static analysis perspective, I always say if you look under the hood, mathematically speaking, it is an NP complete problem. Now we have made waves and have been able to now deterministically provide better analysis with AI, but there is still a bit of a gap. So it's never apples to apples that you can compare one solution versus another solution. So it really comes back to the philosophy and approach of how things are being analyzed. And with CodeQL, the way that we do it, it's designed to reduce the noise, actually find where the true impact lives. So I call it the best fix location. So when you're looking at, the flow, the data flow, the control flow, the semantic analysis that's being applied, you really want to just focus on the points of execution that could potentially cause an incident. That way, your developers aren't spending time going through figuring out, is it a false positive? Are there false negatives, etc. So if the rate of vulnerabilities continues to trend in the way we're seeing in this slide, the end result is that we're going to have a collapse. So the reason I joined GitHub is because I saw that it made sense to have that experience embedded right where the developers live to continue that flow state. I always say plug and play, right? If it's something that just happens naturally without them having to configure, run scripts, switch portals, context switching, none of that, then they're more likely to adopt. That way the solutions don't just become shelfware. So now let's look at AI as the hero, right? I always say there is a path forward in looking at what we can do if we use AI, not just to accelerate the development, but to transform the entire security posture. What if AI helps you get secure through agentic remediation that fixes vulnerabilities at scale, that helps you stay secure through agentic prevention? So it stops issues before they're even introduced. So like in the scenario, remediation accelerates the agents handle all the fixes, so it increases speed and it helps you scale the modern development. And prevention works because it actually helps you see those vulnerabilities plateau. And that just helps you catch those things upstream before they even make it to production. So you're not just looking at keeping up pace with security debt, but you're also reducing it. And this is what we call the AppSec Renaissance. So using AI as a force multiplier for security is not just development speed, but it's also making sure that you have everything you need to succeed without having to think about these steps. That being said, our whole philosophy on this next slide here is to make sure your code is secure and high quality by default. And I mean that by saying that whether it's AI or human or agents creating the code, I know it's bold of us to say this, but all software should be by default, regardless of what it is, included security checks, third-party checks, as well as secret checks. So this isn't just about adding another tool or an extra step. It's about making security just like the natural outcome for building the software. Gartner actually calls this shifting security down. So embedding it deep into the platform. So every generated line of code is verified, updated, holding the quality and security at the highest standards. So I think with this approach, developers won't have to choose between speed or security. I think with the right technology, they'll get the best of both worlds. Let's look at what we have today in this space. We have agentic prevention already. So anytime you work with Copilot and you ask it a question regarding whatever it is you're building, it will automatically do a code QL scan, check for secrets, and look at your third-party libraries. So this is happening naturally. Like I said, you're still going to want to have that additional verification, but as you see in this slide here, when you click through, it's going to ask you, do you want me to run CodeQL? And it does it, and then it reruns it for you. And so it just has that extra layer of protection. Now, what does agentic remediation look like? I think some of the biggest challenges we've seen is just, as I mentioned earlier, with the traditional tools, there's always been a lot of noise because there's never been a right way to analyze applications because it changes based on the language, the compiler, the framework, whether you're actually following best practices in terms of like the way you're designing and architecting. And so with that comes just almost like pushback. And so being able to prioritize those security alerts based on what's most important to the business is key. And what we've understood from our customers is that the main thing that leads them to kind of identify which risks lead in prioritization is if it's something in production, if it's currently live, is it active? So that way they can focus on those first and then go back and like work on any internal projects that may have some security debt, but might not have an immediate impact. That being said, we've done enough with some slides. We're going to show this awesome, cool video just to give you some hype about where we're going. And then after that, I'm going to hand it over to Rohan to actually show you guys this whole experience live.
Hey guys, does this video have audio?
Yes.
Okay, we're going to want to pause and reshare because we did not share audio when we shared our screen today. So sorry about that.
We are live. So
we are. This is, yeah,
it still
evidence,
happened.
everybody. So Rohan, when you, so stop sharing and then reshare your screen, and you'll see there's a little selection on the bottom of the screen that'll say also share system audio. Perfect.
All right. Cool. Let's talk more about this, right? Lupita mentioned that how additional context that can come in as much as possible, it can help prioritization of risk that is coming from different. Oops.
It's because everyone in the chat loved the beat. It just had to come back.
Yeah. All right. Oh. Yes, we are live.
I'll actually go off screen so I can monitor the chat if there's any questions.
All right, I will run through slides very quickly so that we can reach the place where we wanted to talk about. How do you prioritize better, right? How do you prioritize better with more business context, more security context that can help developers and security teams? And I think that's the important piece what we are going to talk about, and that's what this integration is about as well. In fact, I saw in the chat some time back where somebody mentioned that it was all about prioritization and based on the maturity level of the teams involved, right? And in this case, right, how do you prioritize better by bringing in additional context from runtime on GitHub side? If you look at like security app context and how do we typically, what's the anatomy of a security application? Typically, it's going to be first-party code and third-party code. First-party code is code written by yourself and your teams, which can have like your custom code, but it can also accidentally get secrets and credentials into the code repository, as well as third-party code, which is a lot of that is coming from open source and third-party dependencies that you knowingly or in many cases unknowingly would import in your projects. But at the same time, in that projects, those repositories are packaged together in the form of container images or container runtime. The third-party code can come in from there as well. As a developer, you are primarily responsible for the code that you have created, right? And your ownership is around that, whereas security teams are focusing on securing the code that is coming from you, from your developers, but at the same time also coming from those third-party ecosystems like dependencies, container images that can come into your code as well. Because at the end of the day, the risk, both of them represent the same level of risk. If you also look kind of wear the hat of a SecOps persona, their pain point is like there are just too many recommendations, too many security issues, vulnerabilities, findings that are presented to them. And for them, it's very difficult because they are now looking at across the enterprise, across all the application, and look at like who is the owner for a specific issue, right? Who is going to fix it? Who is going to kind of be held accountable for certain risk that comes into your first party code and third party code? And how do you mobilize developers to be able to go on and fix those issues? And it's not just kind of being able to assign ownership, it's also about providing the right guidance to the development team so that they can, number one, prioritize what needs to be fixed, and number two, also identify how that needs to be fixed. From an application security there are just too many alerts. The number of scans is not a problem today. Different type of scanners is not a problem today. The problem is how do you bring in more context, more prioritization to that so that you can remediate faster in the context of the risk that matters the most, because a lot of risk that comes from AppSec may not matter at all. And that's where we'll talk about secure code to cloud workflows that is enabled through GitHub Advanced Security and Microsoft Defender for Cloud integration. Let's start with how the end outcome of that would look like on GitHub from a development and security perspective. Let's go to security section on this demos repository, and we'll go to Dependabot. For those of you who don't know, Dependabot is a dependency management and software composition analysis product. It helps you identify vulnerabilities in all the open source packages that your repositories might be importing. And in this case, this is an organization-wide view of all the dependency-related issues, Dependabot-related alerts that you have open in your environment. And as you can see, there are some 223 open Dependabot alerts in this particular organization. There's already some context in the form of what kind of package it is, whether it is critical or high, whether it's a direct dependency or not, or whether it is a dependency in development or not. But with this integration, and like I said, I'm going to show you the end outcome, you will have the additional ability to prioritize these alerts based on the runtime context itself. So when you as a developer or an AppSec persona see a list of alerts, your natural question is that important, right? The importance can be brought in the form of, hey, is this even deployed somewhere? So we can go and search for has deployment. And now you can see there are, out of those 200 plus alerts, there are only 48 alerts that are open that have an active deployment. And this information is coming from Microsoft Defender for Cloud Integration. And we'll talk about more that in a minute, but already you are much more focused now in terms of being able to prioritize and remediate issues as compared to previously where you did not have this information. But further down, 48 might be just too many, even for some smaller teams, which is where you can go and add filters like runtime risk, where you have runtime risk indicators like critical resource, internet exposed, sensitive data, or lateral movement. Again, indicators coming from Microsoft Defender for Cloud for the artifact, for the workload that is running corresponding to these repositories that are on GitHub. So let's filter on anything that is internet exposed. And you can see now there are only 21 alerts that we need to focus. But these are definitely alerts that we need to focus because these are alerts on repositories that have a corresponding artifact, corresponding container, in this case, running in production, which is internet facing. But at the same time, you already have a lot of information that allows you as a developer and as an AppSec persona on GitHub to be able to go on prioritize things that matter the most. Remember, we started from 200 plus alerts, and right now we are only at 21 of those alerts organization-wide. Now, the question that you might have is, how are you getting this information? I already mentioned this is coming from Microsoft Defender, but where can I review that information on GitHub? So if you go to packages section on your organizations and visit this linked artifact section, this is what we are right now calling it as a virtual registry. GitHub has exposed APIs. These are public API endpoints that can be used by anyone to populate the information about these records. So in this case, let's take example of this Java web shop, which is the repository that we are focusing on. And what we can see is for that particular repository, there were 128 deployment records that were available. And all of these deployment records in this example were coming from Microsoft Defender for Cloud, but you can actually use the APIs to populate it natively as well. The important information that you see here is that there are these containers that are running in production. It tells you even the zone, what's the Kubernetes cluster in this case, AKS cluster name. And of course, all these runtime information about artifacts is linked to the repository, and more importantly, to a specific workflow and build as well, which means you have the ability to pinpoint to a specific code commit which led to an artifact building through a workflow, which is what is right now running in production. But if you remember, we were talking about whether something has a deployment or not as a filter on alerts, which is available on Dependabot and actually code scanning alerts as well. So the presence of a deployment record, which has an active deployment, means that you have code running from this particular repository in deployed. And it has information like critical resources, internet exposed, sensitive data, all that information being populated directly from Microsoft Defender for Cloud and into GitHub ecosystem itself. So this is where you will be able to track a lot of those artifacts in runtime, but their information about that, their deployment records, and it's actually not just deployment records. We can even get storage records if those images were, say, pushed to an Azure Container Registry, and so on and so forth. Now, just to kind of recap what we saw right now, right? What we saw here was the ability to get more runtime context from Microsoft Defender into GitHub, and then being able to use that runtime context to be able to go on and filter Dependabot alerts and actually even code scanning alerts. These filters are available for both Dependabot and code scanning. So if we'll take an example, in this case, code scanning has 114 open alerts, but we can again look for internet exposed ones. And now there are only 18 alerts that really matter the most. Rest can wait, first. But first, these 18 alerts needs to be resolved. All right. This was on the GitHub side, right? The application security persona, or the developer who is, or security AppSec user who is constantly trying to prioritize what matters the most on Dependabot and CodeQL. But let's also look at from a security operations persona. This is Microsoft Defender for Cloud. And what we are doing is right now looking at the attack path analysis for certain subscriptions. And there are a bunch of recommendations that are present here. But let's try to kind of drill down and focus on a few things. I'm going to look at risk factors that involve internet exposure and sensitive data. If you remember, these are the same risk factors that have propagated from Microsoft Defender for Cloud to GitHub. But let's go and apply this. And I'm going to add one more filter where we'll say that the resource type is storage account, because we want to identify recommendations that where the target could be a storage account, which might be processing sensitive data. And let's try to find a relevant workload here. Yeah, let's take a look at this one. Internet exposed container with high severity vulnerabilities that could allow lateral movement to a critical Azure storage account. Now, a lot of information is tied kind of end-to-end by Defender here. In this case, you can see is that there is a running container, Java Web Shop, which is associated with the storage account, which is processing a lot of sensitive data. It's a crown jewel storage account. This container was built through a particular container image, which is on Azure Container Registry, which is associated with the GitHub repository. So Defender and the Microsoft integration with GitHub is able to do this code to cloud correlation, where we are now able to automatically go and associate a GitHub repository to running container images. And for this to work, you have to go to your Defender account and enable your connections essentially by making a connection into GitHub using the Microsoft DevOps security app, and that should be sufficient. So, like from a call to action, if you are a Defender and GitHub Advanced Security customer, make sure that you have enabled the connection from Microsoft Defender to GitHub. And if you already have one, you might have to, and you have done it like a few months back, you might have to update and review the permissions of the app. But that's all you have to do. But going back to this attack path analysis, it was identified that this container was part of a pod, which is essentially exposed through a service, which is internet facing. But let's go back and look at the container and what are the recommendations associated with this container. And there are quite a few. We'll take example of, let's say, update Lodash, right? And in this case, if I go to associated CVEs, there were some CVEs identified by running a scan on the container itself by Microsoft Defender, but it was able to do map and correlate those CVEs, those vulnerabilities, to an existing GitHub alert as well. So it is able to identify that the same CVE was identified by GitHub using the Dependabot scan by scanning the code repository. Same time, the same CVEs exist in the runtime container itself as detected by Microsoft Defender for Cloud. Let's take another example now where we can go back here to containers, recommendation. I'm going to look at update busybox. Now, in the associated CV section, let it load. You don't see a GitHub related alerts here. And this is perhaps, if you remember one of the slides that we're talking about, these vulnerabilities are not coming from the code or the repository itself, but from the image that was built, or the base image where the repository or the code exists now. But it still needs remediation, right? And you can go and assign this particular issue directly from Microsoft Defender for Cloud into GitHub issue itself. So I can go and click on take action. In this case, I've already done that once. So if I click on view issues on GitHub, to the update busybox recommendation has been essentially converted into a GitHub issue. You can see there are labels for Defender for Cloud. It has all the details that can help developer fix this issue in the base image itself and being able to reduce this risk. Now, let's go back and also look at the additional things that can happen, right? With your connection from MDC into GitHub, you will be able to see a lot of recommendations coming from GitHub directly. So in this case, you can see there's a recommendation which says GitHub repositories should have dependency vulnerabilities resolved. GitHub repositories should have code scanning findings resolved. So if I click on code scanning findings, you will be able to see all the code scanning findings corresponding to that repository as identified by code scanning on GitHub, but now on Microsoft Defender. So from a SecOps perspective, you have visibility into not just the alerts and findings that are identified and detected in runtime by Microsoft Defender, but also by vulnerabilities and issues identified by GitHub now on Microsoft Defender for Cloud as well. All right. So that's essentially the key aspect of this integration, right? If we kind of take a step back and try to revise what we just saw, there were kind of two things here. One was, as an AppSec user or as a developer, if you want additional context about the vulnerabilities that needs to be fixed through GitHub Advanced Security, you can bring in a lot of additional context from Microsoft Defender for Cloud. But as a security operations, as a cloud security persona, if you want visibility on the workload, on the risk that those workloads represent end-to-end, not just the runtime one, but also from GitHub, using its SC and SAST findings and secret findings for that matter, you can bring all of that information on Microsoft Defender as well. That being said, let me jump into the slide and talk a little bit more about this integration. There were two aspects to it. Obviously we mentioned about being able to kind of leverage the third-party virtual registry platform on GitHub to be able to get all of that runtime context into GitHub from Defender. But that's combined with advisory database and CVE container information gives you a holistic remediation platform on GitHub, which, by the way, at the end of the day, you can go and assign code scanning alert to Copilot, and it can go and remediate those vulnerabilities for you. So the agentic platform in the form of coding agent is present there to be able to help you remediate those findings, those issues, once you have identified what are the issues that you'd want to focus more. So don't need any trade-off, right? We at the start of the session, Lupita talked about the kind of friction between these two functions, but that does not necessarily have to be the case. If these two functions can work, hand in hand, closely together with the abilities that this integration provide to our customers. More details are present on this blog, and I can answer more questions also, if there are any chat. But that was it. Lupita, do you want to add anything?
Can you guys hear me? Awesome. Yeah, we actually have some great questions in the chat. I think we can kind of work from the top down, if that's okay. So I believe the first one that came through was how to configure Dependabot at the org level.
Dependabot configuration at the org level is something I don't want to say something which I'm not sure. So I think I'll probably find something later and we'll try to kind of post it. But I think there are, I don't have the answer at the top of my head. So I'll have to kind of refrain from giving any answer which might not be accurate at this point.
Yeah, and I think that's more related to the GitHub configuration. So within GitHub, if you have the Dependabot license, or it comes with all enterprise accounts, but there is some additional features if you have code security license, which then you can go ahead and apply the configuration there. But once you kind of get that going, I think more so the interesting question that we have here is regarding the Defender connection. So one of the things that came up was, do different versions of the binary deployed get tracked differently?
Yeah, but before that, I think I can answer the previous question, right? Like,
okay.
If you have GitHub Advanced Security licenses, you should be able to go to the Advanced Security Configuration settings and create a security configuration which includes like config that is for secrets, for code security, and for dependency scanning as well, which is where you can enable Dependabot alerts and security updates and essentially apply it across all of your organization. Right. Okay, let's go to the next question. Do different versions of the binary deployed get tracked differently? So the way it works is, if the artifacts that you are building would be essentially created through GitHub Actions, right? And GitHub Actions would, and as a result of that, GitHub would have the information about all the artifacts. So if you go to packages and linked artifacts, you will have the details of all different versions of that artifact itself. In this case, it's just a specific SHA, but if there are like newer versions released, you will be able to have the information. In this case, you can see this is like 1009 and this is 10010. So all of them are being tracked separately because of their checksums. And yes, the short answer is the different versions will be tracked separately. And let's say a new version does not, in this case, was not internet exposed and sensitive data, so you'll not have that information in the alerts. I hope that answers the question.
Great. And then the next question, does it track dependencies, first party, third party, open source separately from the base application? Real curious of the dependency management on deployed assets to VMs.
So Dependabot focuses on the dependencies that you can identify in the code base itself, right? And typically that happens through manifest files, right? It's essentially depending on which ecosystem, which package management, which language framework that your your code represents. You will be able to identify all the dependencies primarily that are open source and third party. Anything that comes from container images, right? I think that will be more coming in the images are built and then scanned through Defender for Cloud, either by image scanning or runtime scanning. So real curious of the dependency management on deployed assets. So yeah, I think once it is deployed, it will be a combination of the third party and open source packages or dependencies coming from code, as well as the base images that would have been, that base images that have their code running and then live in production on Defender, on Azure rather. Okay.
Awesome. The next question is, can we also connect Defender for Cloud with our GitHub Copilot spaces? Is there an MCP server specifically for security or just in general, such as Azure Copilot, which is not really good?
Yeah, I think Defender for Cloud, my understanding is that there is a work going on an MCP side of things, like in exposing some of those capabilities through an MCP server. I will not speak for the MDC team, but I know because we work closely with them, I think they are working on potentially an MCP server in future. So stay tuned for that.
Excellent. Any other questions? I'm looking at the chat here.
Yep.
I love the engagement, by the way. Seeing where everyone's tuning in from. If there's no other questions, then I think we can go ahead and wrap up. Hopefully this was helpful. As mentioned, we have these sessions every few weeks, so feel free to register for them all. Come back on. We always have a rotating set of speakers that come live and talk about topics that you guys want us to discuss. So with that, I'll go ahead and thank everyone for their time and sign off.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.